This is Mr. Lee with a recap of the law of sines. The law of sines is useful for solving triangles that are not right triangles. So for an obtuse or an acute triangle, we use the law of sines. And the law of sines tells us that for any triangle, there's this proportion that holds true. And the proportion is that the ratio of the sine of one angle, so the sine of angle A, that's the angle, so the sine of angle A divided by the length of the side A. So the little letters are the side lengths, the capital letters are the angles. So the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. Okay, so that is our proportion. We also know, because of the reciprocal rule, that we can flip these. The reciprocals of these ratios also form proportions. So A over sine A is equal to B over sine B is equal to C over sine C. So the question is, how do we apply this to problems? So here's an example from the textbook. And it says that there's a lake. And this lake has three picnic areas around it. There's the north picnic area, the south picnic area, and the east picnic area. And a surveyor is looking at the angles and the distances. And he notices that angle A measures 71 degrees. Angle C measures 60 degrees. And he notes that the distance from A to C is exactly 150 meters. So we want to know, what is the distance from A to B? How do we solve that? Well, we do not have a right triangle. First of all, since we have these two angles, can we come up with this angle? Yes, we can. We use the triangle sum theorem, and we notice that 60 plus 71 is 131. And so subtracting from 180, we find that angle B measures 49 degrees. But we want to know, what is this distance? That's where you use the law of sines. The law of sines tells us that sine B over B would be equal to sine C over C, where this is C, this would be B, and this would be A. Because remember, the letters are opposite. Okay? So little c is opposite big C, little a is opposite little a, little b is opposite big B. Sorry, little a is opposite big A. Okay? So this is the part of the proportion that we want to use. Sine B over B is equal to sine C over C, because of the given information. So sine B would be the sine of 49 degrees over B, which is 150, is equal to the sine of 60 degrees over C, which is our unknown right here. That's what we're solving for. So rearranging this equation, actually, let's go ahead and use the reciprocal rule. So we know that with this proportion, we can flip these or use the reciprocal of both of those and still have a valid proportion. So that gives us that 150 over sine 49 degrees is equal to C over sine 60 degrees. So we've just taken this and we've taken the reciprocal of that equals the reciprocal of that right here. Okay? Then in our trig table, we just look up the sine of 49, that's a number. We look up the sine of 60, that's a number, and we substitute. Okay? Go ahead and look up those values now. So for sine 49 degrees, use the trig table. You just go to 49 degrees, and the first column is the sine, so it's 0.7547. Sine 60 degrees, we know is 0.8660. And then to solve for C, or to get C all by itself, we just multiply both sides by 0.8660. So C is equal to 150 times 0.8660 divided by 0.7547. And then using our four-function calculator, we get 172.12. And remember, the unit of measurement is meters, so this would be meters. So the distance from the north picnic area to the south picnic area is approximately 172.12 meters. And that's it.